Hello Internet, welcome to fifth video of MERN stack tutorial series. In last video, we reviewed GitHub version control workflow, refactored GraphQL code for modularity and maintainability, began designing the schema for book club project along with resolvers for mock data. We also walked through a query parameters and positional argument to resolvers. Finally, we pushed the code to GitHub and merged the code in remote and rebaselined master on local. Now we are ready to start coding and continue designing the schema for our book club. So before that, again as the regular practice, let's create a new branch. I'm calling it video 5 and enter. Okay, so video 5 branch is created. Before coding though, I would like to address one of the pain points while developing this code. That is, whenever we are making the changes and we want to see the changes on either play area or playground or run the queries and see how the changes we made affected, we had to manually terminate and restart the server, Express server. Luckily, we have a package which will ease that pain point, and that package name is Nodemon. So let's install Nodemon, and uh, we need to save it as save dev. The reason for that is we are installing this Nodemon to ease the life cycle or ease the development process. This is not really needed for running this application in production. So we need to distinguish the packages which are needed for application run in production versus the packages which we need only for our development environment. Nodemon is one of the examples. So let's install Nodemon. Nodemon is installed now. Let's go and check the package.json. We have another dependency node. This is different than the regular dependency. This is notified as dev dependencies, and we have Nodemon 2.0.7 version installed. So this is how package.json distinguishes the regular packages which are needed for application run in production versus the packages we need only to be run in development. So now how this Nodemon will help us. So in the script, we need to create another script. Right now there is a placeholder test script. So let's call this as whatever we can call it whatever we want. So let's call it as start server. This is how we will execute this script. And the script what we are going to run is we are using the Nodemon and and we have to run the index.js. Now let's save this package and on the terminal let's say npm run. Instead of saying that node index, we need to run the start server script which we just created. For that we need to use npm run command and the script name. Now the Express server is running as we ran the Nodemon script. Now the advantage of this Nodemon script is this package automatically watches the all the JS extension files. So let's say if I make any change and if I save it, you notice here on the terminal the server is automatically restarted due to changes, and we don't need to manually terminate and restart the server. Our Express server is running and we have our prototype on the right hand side. So let's resume building our schema. On the bottom of this book details page, we have this view other books by same author. So let's try to define the queries to fetch data needed for this view. Right now we have defined author as a string on the book type. For satisfying the view on the UI, we need to look up books by this author key. Since we need to look up the books by author, a free-form text of author is not suitable. We need to put some constraints on it. So one of the ways to do it is to define author as a type author instead of a string. Now we need to define what that author type is. So let's define that now. Type author. This needs to have an ID of its own. Let's define author name, a string, which is mandatory. And right now this view on the UI looks a little bit sparse for this bottom section. So we can do a little bit better here. Instead of just saying other books by same author, we can put the actual author's name, and probably we can put some accolades or any prizes the author has won at the bottom, just to make a little bit more advertisement. So let's put that field. Let's call it as accolades, and that is a string. And let's keep it as not mandatory. Now this is perfectly fine. We can continue to build the schema for this like this, and we need to define the query for author here in the same file. However, this is not one of the best practices. From business perspective also, book is a different entity, author is a different entity, and when we come to the users or members of the book club, that is a different entity. So in future, when we have any change request or any enhancements, it is better if we have all these entities in different modules. So let's create that different files. In typedef folder, let's create one more file for author typedef, and let's bring in everything in the index typedef to author typedef. We don't need these queries for books here. We don't need type book. We need only the type author, and let's define a query called author which takes in an ID which is mandatory, and it returns an author type. Let's save the changes we did in author typedef. Similarly, we need to create a separate folder or a separate file for book. So let's do that now. Let's call it book typedefs.js. Let's bring in everything from index, paste it here. So this book query, and book typedef are relevant here. What is not needed is the type author. So let's call this book typedef. Let's export book typedef here, save it. Similarly on author, let's call it author typedef, and let's export author typedef. So on index, we need to simply merge these two typedef. So for that, first we need to require we need to require book type def. Let's call it book type def, and we need to require author type def, and let's call it author type def. Then let's export these two module.exports, and we can pass them in a array. Let's save it. Okay, so let's see. First point is our Nodemon script is rerunning. It is restarting on every JS change, which is a good enhancement since last workflow. Now, when we made these changes to index, we are getting an error. So what kind of error we are getting? The error is there can be only one type named query. So let's try to understand what that error means. Let's go to book type definition. Here we are defining a query root type. Also in author, we are defining a query in the root type. So there is that conflict. So there is a simple fix for it. In the index, we are first calling it as book type def. So here the query is defined for the first time, and any type defs where any uh, queries are defined at the root level, we can simply use extend keyword. So what will happen is when those two are merged, these two schemas are merged, initially the first type query is found. So this is the first time there is no conflict here, and next time it looks it gets the extend type query. So it simply merges those two root types. So let's save, and the Express server is working fine now. And just to be sure, let's refresh our GraphQL playground. Let's look at the schemas, and we see the author type, the book type, and even the author query, right? So we define these books and book in a different module and author in a different module. So the GraphQL merges these two schemas, or it's also called as schema stitching, and it gives in one root query. We defined author type. Now let's define the query to satisfy this view. The query name is books by author. It takes in a parameter which is mandatory, that is author ID. We need to pass in author ID that is of type ID, and that has to be passed to this query. Now what is the return value of this query should be, because these are multiple items, so that means that is an array. Each of the item is what? Each of the item is a book. So let's call it as book here. Now scrolling up, let's tackle this section of reviews for each book. So each book may have a list of reviews. So let's define that field on type def. Let's call it as reviews, plural form. It is an array because each of this book can have multiple individual reviews. So let's reviews is an array of individual review. So we need to define what is that review now. Type review. So review, let's keep it as capital R review. So what does each individual review contains? First is the text. Let's name it as review comment. It is of type string, keep it as mandatory, and also it needs to have a rating. So how this works is every individual member who is reviewing will give a or text, and then the member will rate individual book. That those individual ratings by individual members will be averaged, and that average rating will go at the book level. So we need to have a rating field, which we will define as int, and int should be this should be mandatory also. So again, individual members who are reviewing these books will provide a text and a rating, and individual ratings will be averaged to get a book level rating. Finally, we need to have this avatar and name of the user. So for that, we need to have another field called reviewed by, and it is of type user. We need to define what this user type is. Let's define this user type. For that, let's go to folder of type dev. Let's create one more file, user type dev.js. Let's call it constant user type dev is equal to template string, then type user. Let's leave it blank for now. Module.exports is equal to user type devs. Let's save it. Let's go to index and user type dev. Let's require slash ask user type dev, and let's include that in index exports user type devs. Now we need to define the fields. The type user or any root type cannot be empty. So let's say user has name, save it. To define the actual fields needed in type user, let's go to the user journey in our prototype. So the user journey starts with login. So before we log in, we need to have an account. So in the account, we are asking for email, password. So in the user type, let's take out this name. We need to have email of type string, and before that it needs to have an ID, non-nullable. We need to have email, and we need to have a password. Password is also of type string, and the confirm password is merely for validation. Obviously we don't need to save it in the database, or we don't need to call it or retrieve it in the GraphQL. Once we click sign up and once we click login, we are on the landing page. So let's go to the profile. So in this profile, we have the name, the email. So let's define the name here. And also we need to have image. Let's call it as avatar. Similar to book, we will have a string. That string is URL to the actual image, which is pointing to this avatar. And also in the name, I can't make it as mandatory because in the registration we are not asking for name. So a user without name is a valid business case. So name is string, it can be a null to start off with. Okay, so that takes care of the initial section of our profile page. Next, we have a middle section. This is books owned. So we need to have these fields, books owned. So books owned is a list or array, and each item within that array is of type book. Now we need to have this books rented. Again, the books rented is an array. It is of type book. Books rented is sort of a misnomer. We are not really renting, but we are borrowing. So let's call it as books borrowed, and on UI also we will change it. On the books owned, we need to have another field, not just the book, but also another field or another flag indicating whether this book is already borrowed by someone else. So instead of just book, let's create one more type, book owned. So books owned is an array of book owned. So each book owned type book owned, all the types starts with capital letter by convention. It has book, book is of type book, and it has another flag is available. This is of type boolean. So this array books owned is an array of book owned type. Book owned has two fields. One is a book, which is of type book, and is available is a flag, which is yes or no. It's a boolean type. Switching our attention to queries, let's go back to the user journey. So for user, the very first thing to do is to register. So let's type a query to handle that operation. Now registration will add a user to the database. So that is add type. It is not read type query. So all queries or all operations other than read type queries are defined in mutation. So we are defining a new root type called type mutation. So in type mutation, we are defining an operation called register. So in register, there are two values which are passed. One is email of type string, which is mandatory, and also password of type string. So once the registration is complete, let's define the return value. The return value, we are defining it as a boolean, and it has boolean. So if the registration is successful, we will get a true value, and if registration is not successful, we will get a false value. Now this type of variables passing to mutation, like we did for query, works Okay, there is no issue, there is no technical issue with this type of convention. However, the best practice for mutation is to define another user type called input rather than giving individual variables. So let's cut this and define input. Input type is registration input. So we need to define what that registration input is. So input registration input and then paste the values we had defined in the query. So this is a best practice and it has few advantages over passing individual parameters to type mutation. So in registration input, we would need access to the confirm password field also. Confirm password of type string, it is mandatory. So here in registration or register mutation, the registration input is mandatory. So let's keep it as exclamation mark. Let's save it. Going back to the login process, we need to have a query or a mutation for the login process. So similar to registration, let's create a login mutation. Login input type as login input and it should return a string. Let's define that input login input login input and it would need just email and password. So once the login, when we implement the login process and if the login is successful, it should return a token. So we will talk about that when we implement authentication and authorization. Let's stop coding here and push this code to GitHub. Stop the terminal with Control C. So in the last video, we used the IDE shortcuts or IDE GUI to push the code. So let's try the commands to add or push the code to GitHub. So the first is git. We need to add all the changes we made. So we can do that by git add dot command. Then we need to commit it with a message. We'll say message as video file. We started off with Nodemon. We did schema stitching and schema enhancements. Okay. To push these changes, git push origin video file branch. Okay, so on the remote, we see that a video file has been pushed. So let's do compare and pull. We see the message here. We will get the pull request created. GitHub is doing automatic checks. There is no conflict. Let's merge and confirm the merge. So now on the remote, we have video file merged with the master. Now on local, let's switch it to master, git checkout master. Okay, so we are on the master branch To sync local master with the remote master, let's run git pull command. Okay, so now our master is synced with the remote master, which has video file changes also. So in this video, we covered Nodemon, schema stitching, we implemented, uh, we enhanced the schemas, we talked about mutation, input types, and also we did the GitHub version control via commands. In next video, we will implement the database, that is MongoDB, and start implementing resolvers for the queries which we have defined. That's it for this video. See you in next.